Hi students, welcome to Year 10 Science and video number 8 in the space or universe topic, the Big Bang. So we just want to quickly touch on a few of the key aspects of the Big Bang theory. We blew up little balloons in class to show how the universe is expanding. So we've got a kind of a bit of an idea about how this works, but we want to just make sure we're clear about the theory itself and also the evidence that supports the theory. You remember that a theory is actually an explanation. Scientists develop theories as explanations for their observations, and when we consistently find that our theory can be applied in a consistent way to explain all of the observations that we see or all of the data that we collect, then we know that our theory is sound. If our theory no longer explains some of the observations that we see, or we gather data that counteracts or conflicts with that, then it means we need to change that theory. We need to update our models in order to reflect our new observations, new information. This does happen a lot with the whole idea of what happens to the universe, because we've been developing technologies that have allowed us to make much more accurate, much more consistent observations of the universe, and as a result we've been able to put together more consistent pictures. But sometimes what happens with those observations and that data is that we continue to support or at least reinforce what it is that our theory is explaining. So the Big Bang theory then is simply an idea that the universe began as an infinitesimally small point. This is often referred to as a singularity, a really dense concentration of matter in space that had a huge amount of energy. This thing, we don't know exactly what it was, but there was a huge amount of energy all locked up, held in this tiny little space. And what happened in the first couple of minutes of the universe is what has really shaped the evolution of the universe after then. The idea of the Big Bang theory was in fact Edwin Hubble's, and he's the one for whom the Hubble telescope is named. The Hubble telescope is quite an important particular device, as this is one specific device that we've identified as providing much more important or precise information than we've had before. One of the problems with most ground-based telescopes is the distortion that's created by the atmosphere that sits between the telescope and space. By placing the Hubble telescope beyond the atmosphere, it allowed us to improve significantly the quality of the images that we get, and also to examine some of the different types of data that we can actually collect and what we can use to support things like the Big Bang theory. The idea of the Big Bang theory is you start with a little concentration, and that then you get this explosion that moves out in all directions. This is the whole idea of the Big Bang. Everything condensed into a very, very tiny space, which then blew. Expanding universe is not a new concept. In fact, it's almost 100 years old now. And the data that's being collected continues to support this idea. Does that mean it's the only idea? No. There are other ideas like the steady state theory for what's happening. And even an idea that we have successive bangs and crunches as the universe expands out and then collapses back on itself in a kind of seesawing kind of a way. But the Big Bang theory is certainly one of the theories that's endured for quite a significant period of time, and is believed to be the point where both space and time were created. Hubble's discovery was this whole idea that the further away that galaxies were from the Earth, the faster that they were moving. So if we're at a particular point, what we find is that things are moving away from us, stars, galaxies, planets, all moving away from us, and the ones that are the furthest away are the ones that have moved at the fastest speed. And that kind of makes sense if you have a whole group of people standing at a starting point, and then you fire a gun, the fastest ones get further away quickest. Of course, what that means is that if you turn each of these arrows back on itself, then what you find is that everything comes back to a central point, and that's the point that's believed to be the location, or if you like, the center of the Big Bang. This idea of pulling everything back to the center and then an explosion which has pushed everything out from that center is the whole idea behind the Big Bang theory. But is there any specific evidence that we can identify? Well, probably the most important area of evidence is the whole idea or effect which is known as the Doppler effect. This was first introduced by Christian Doppler and probably is most familiar to you in terms of sound. When you stand on the side of a road and a vehicle with a siren on it comes towards you, the waves get compressed, so the frequency gets higher. As it moves away from you, the vehicle is almost pulling that siren away from you, and it pulls the waves into longer waves and drops their frequency. So this idea of changes in frequency or pitch, if we're talking about sound, higher notes and lower notes, can also be applied to light. The difference with light is that we have a spectrum of light that runs from the red through to the violet part of the spectrum, and this is the part of the spectrum that we know as visible light. So this is the Roy G. Biv stuff. So red, orange, yellow, green, blue, indigo, violet, the whole colours of the rainbow thing. Now what we find is that when objects are travelling towards us, that is, they're getting closer to us, we find that the wavelengths of light that are emitted by the elements inside of those objects, usually we're looking at stars here, so the most common ones that we look for are hydrogen and helium because they're the dominant elements in the center. Hydrogen fusion reactions are what powers stars. So we find a certain spectrum, which is a series of lines like the ones that I've drawn here, not exactly like this, but just different colors to give you a look. And what we find is that the same pattern of colors can actually either be shifted to the left, which is towards the red end, or shifted to the right, which we can call the blue or the violet end. And so the same pattern of lines move to the red end tends to say that that's getting longer, so it's moving away. And ones that are shifting towards the blue are getting shorter, so they're moving towards us. This idea of spectra, that is light that's being emitted from stars in certain bands moving towards the red end, so the line sort of coming just a little bit further to the left, or in the blue coming a little bit further to the right. I know this would look more impressive if all the colors were the same, but you get the idea. These ones are all going a little bit this way, and these ones are all going a little bit this way. So it's the same pattern, it's just moved to the left or to the right. This is a piece of evidence that we have. We know that we can identify spectrum where there is the same series of lines like barcodes, and they have been moved one way or the other, telling us that the object that's emitting these is moving towards us and moving away from us. The greater the shift, the greater the speed, and this gives us some real data to support the whole idea of the Big Bang theory. There's a lot of other areas, but that's probably enough for this particular video. So have a look and see if you can just order some key evidence in support of the Big Bang theory, and just understand that that whole idea of expanding universes from a central point is what we're talking about when we talk about Big Bang. Thanks for watching.